Hello everyone, today we are going to solve the Leetcode question 2434 using a robot to print the lexicographically smallest string. The question says that we are given a string S and a robot that holds an empty string T. We can apply any of the following operations until S and T both are empty. The operations are remove the first character of S and give it to the robot, which will assign the character to the string T. And the second operation is that we can remove the last character of string T and give it to the robot. The robot will write the character on a paper. Finally, return the lexicographically smallest string that can be written on the paper. So the question wants us to return the lexicographically smallest string by performing this operation on the given string S until both S and T becomes empty. Okay. Now, let's see what is the lexicographically smallest string. The lexicographically smallest string is a string where the first character which differs, we compare the first character which differs. The string with the smaller character is the smaller string in lexical order. Let's understand this the statement by taking an example. So in this case, the first string is A, B, C, D, and the second string is Z. The first string is bigger comparison to the second string in terms of length. But in lexical order, as we know the definition, the first character which differs is compared. And in this case, A is smaller. So the first string is lexically smaller than the second string. Let's take another example. In this example, the first string is BBCD and the second string is BBAD. And we are going to check the first character which differs. And the first character is same, so we will consider this. The second character is also same, so this won't be checked as well. The third character which differs is C and A. And as we know that A is smaller than C, in this case, the second string is lexically smaller than the first string. Now coming back to the question, we need let's see the example one and perform the operations. We have the string S, a string T, which is initially empty, and a string P, which will be our final result, and it is also initially empty. So the first operation says that we need to remove the first set of string S and give it to string P. Removing the first set of string S and giving it to string P. Then after removal, again the first set of string S, giving it to string P, and removing the first character and giving it to string P. Now the string S is empty and the string T becomes ZZA. Now performing the second operation on string T, removing the last character and giving it to P, removing the last character again, giving it to P, removing the last character and giving it to P. Now both the string S and T are empty and P holds the string A double Z, which is actually the lexically smallest string in this case. Now applying the same sequence of operation on the example 2, where S equal to BAC, initially T is empty and P is empty. So performing the first operation, giving B to C, then removing the first character again, and finally P goes to T. Now T becomes BAC, and now performing the second operation, removing the last character from T and giving it to P, C, A, D. In this case, after both the string S and T becomes empty, we get CAB as our result, which is actually not the lexically smallest string which we can get. So from this, we can clearly state that the order of the operation matters. Now let's see what should be the actual order of the operation for the second example. We have BAC at the string S, and from the operations, we can see that the second operation, for performing the second operation, the last character of the string T will be moved to T. But in this case, the T is empty. So we cannot perform the second operation. We perform the first operation. We move the first character of S to B. Then in second step, we can either move the last character of T to P, or we can move the first character of S to T. Here we have to decide which will be the better option. And for a lexicon smaller string, we know that the smaller character should come first. So if we move the last character of T to P, our first character at P will become B, which is not the smallest character which we can take from the entire string BAC. The smallest character is A. So we cannot perform the second operation. We need to perform the first operation. We move A to the string T. And at step 3, we can either move the last character of T to P, or we can move the first character of S to T. In this case, we need to again decide which operation should be performed. If we perform the first operation and move C to T, after that we cannot perform any number of the first operation. We need to take this to P, which will again not make the lexicography smaller string as we have A. So we perform the second operation, we move A to P, and at step 4 we have options. We can either take C to T, or we can take B to P. And if we perform the first operation, we take C to T, then after that we'll have to move C to P, which will not the which in comparison to moving B is not the lexically smaller string. So in this case, we perform the second operation and take B to P, and after that we can only perform the operation one. We take the first character of S to T, and again we can only perform one operation. We take the last character of T to P, and here we get our final result as ABC, which is the lexically smallest string we will be getting. Now we know that we got the sequence, but we need to develop a algorithm which will implement the sequence. So let's see first that which data type, which data structure we will be needing to solve this question. For T, we know that we can remove the last character of the string from we can remove the last character of the string and use it. And while inserting also, we remove the first character of the string S and append it at the end of the T. So from this we can see that on T we are performing the operation at the end only. So we can take the T as a stack, and from S, in case of S, we are actually doing an operation in the sequence such that if we have the smallest character, the smaller character in S comparison to the top character of the T, then we will be performing the operation one. Like taking another example, in this example we have the given string S equal to BAC. So um, and we have the same two operations according to which we will be moving from left to right on S, and breaking down these operations more, we can say that at any point we can actually print the current character we are facing. Like if we want to print the character we are facing, we need to do the operation one by taking it to T, and again performing the operation two by moving it to P. By doing the operation one to consecutively, we are actually moving the character from S to P directly. And um, another thing we can do is we can take the top character of T at any moment of time. Um, and from this, we can take a greedy approach that we want the smallest character present in the string at the beginning. For better understanding, let's take some extra variable to understand this. Like okay, let's mark the top character of T with a capital T, and the smallest character present in the remaining string of S with M. So here we can get three conditions, which are T is greater than M, or T is less than M, or T is equal to M. Again, T is the top character present at the stack, and M is the minimum character or the smallest character present in the remaining string. Remaining string means if let's say we have already moved the BAC part to the stack, then the top character will be pointing to C, and in the remaining string BCA, the smallest character is A. So M equal to A and P equal to C. And the greedy approach will be such that we will try to put the smallest characters of the string at first. We want both the A in the ideal case, like let's say we can um, not performing this operation in all the combinations. The smallest string will be double A, double B, and double C. So we will try to perform the operations in the sequence. We may reach the sequence double A, double B, double C, or we will try the string closest to this sequence. So first we'll try to get the A in the beginning, then we'll try for the another A, then B, and so on. So for T, we determine that it will be a stack, and for S, we need the smallest character remaining at the remaining string. So for that, we can take a map, or in simpler terms, we can take an array of a frequency table type of array, and we will initially in the pre-processing part, we will make the frequency table of the string S, which will give us the values of number of times A is present, B is present, and C is present. In this case, I have taken ABC, but we will taking for the entire A to Z. In this case, A will be 2, B will be 2, and C will be 2. This will be done in the pre-processing part, and in the main processing part, we will be checking for these three conditions. So initially, our smallest character is A in the remaining string, as the entire string is in the remaining part. A is the smallest character, and the top element is null, as the stack is null initially. So in this case, as the stack is null, we will be putting B or the first character into the stack, as we are forced to do the first operation. We cannot take the second operation. So if the stack is null, we will be performing the first operation. It is like a base case type of. Then we will again check that, and yes, after putting the character into the stack, we need to update the frequency as well. B becomes 1, A and C remains the same. So now M is A, the smallest character, and T is pointing to B. So the condition we get is T is greater than M. As we want to take the smallest character into our result, so won't be performing the second operation of moving T to P. So the remaining operation, moving the character from S to P, that will be. Now the T is updated and now pointing to A, and we update here, A becomes 1, and now also M is pointing to A. The first character is C in S, but the smallest character present in the entire remaining string is A. So M is pointing to A and T is also pointing to A. So we get the condition of equal, T equals M. And as in this case, both T and M is equal, we can, and we have two operations, moving the character from S to P or the character from P to P. In this case, we will be moving the character from P to P, because if we perform the other operation, we'll keep on updating the T, moving the characters from S to T, and at the end we reach A. And after that we print that A to P. Then to go back to the previous A, we'll be forced to print the characters in between, which are C, B, and C again. So in this case, we can take the last A afterwards, but we need to take the current A, which we will be taking. We remove A from the T and put it at our result. Now again, T is pointing to B and M continues to be A. So we get again the condition that T is greater than M. So we remove or we perform the first operation, we remove the character from S and bring it to C. T is updated to become C, which is again greater than M. So we keep on performing the first operation B. T is again updated to B, which is again greater. So we again perform the first operation, T becomes C. And now again M, and yes, the frequency table will be updated. In the remaining strings, there is only one A, 0B and 0C. So M continues to point at A and T points at C. So again we get the condition greater. So operation 1 is performed, A is removed and kept at the top of the stack. Now we get that the remaining string becomes empty. When we encounter such case, the remaining string becomes empty, but we need to compare T and M, right? So we give the value Z to M. It is like another basis we need to follow so that we can now bring the stack to P. This we will give the value Z to M only after the frequency table becomes empty. So now T is pointing to A and M equal to Z. So we get the condition T less than M. So we pop the top element and give it to the result, which becomes A, again smaller than Z, again smaller than Z. Sorry, I basically wrote the Z here. It will be C, and now comes B, then again C, then finally B. And now both S and T becomes empty. So this is our final answer. Double A, C, B, C, B. In this case, we have the smallest character at the end. Now let's see another example. In this example, we have the given string S equal to BC, ABC. And so the frequency table shows that A have 1, B have 2 occurrences, and C have 2 occurrences. And M, which will be the minimum string, is currently pointing to A. And capital T, which will be the top of the stack, currently null. So as we know, the basis, we will first move the first character of S to the stack. Then you will check. In step 2, we will be checking M points to A and the top of the stack is B. So we get that we have the smaller character still remaining in the string. So we perform the step 1, I mean the operation 1. We take the first character from S to T. Again, now also the smallest character is present in S. So we take the first character and put it at T. And while doing this operation, we will be updating the frequency table as well. Now we have that A becomes 0. So this means that in the remaining string, A is not present. So M gets updated. Now M points to B. Now we check that M equal to B and T equal to A. So T is smaller than M. So we take the character from T and put it in our result. Then again we compare that M and T. We get that M is pointing to B and T is pointing to C. In this case, M is smaller. So we perform the operation 1. We take the past character and put it at B. Now, again, frequency table gets updated. This becomes 0. So now M points to C and T points to B. In this case, again, T is smaller than M. So we take the character from T to our result. And now again T and M becomes equal. M equal to C and T equal to C. So we take the character from T to result. Now T is pointing to B and M is pointing to C. So we perform the operation 2. We take the last character of T to our result. Now T becomes null. So we bring the character from S to T. And as we know the case that when S becomes null, we give the value Z to the minimum character. And comparing Z and C, we know that C is smaller. So we move the C to our result. And our final answer becomes A, B, C, B, C. This is the lexicography smallest string which we can get by performing the operations. Now let's see the code part. Coming to the code part, we have taken the stack st for t and a string builder re for a result and the frequency f frequency table for the string s. In the pre-processing part, as I have said earlier, we will be um, filling the frequency table f for the string s, which is we take character and minus it from a to get the index, and at the end of this for loop the frequency table will be completely filled with the string s, and initially we give the value to the mean character. This is n, like in the explanation I have written n. I have taken here the mean character for the remaining string and initialize it with a. And now the main processing part, we will be traversing the string s from left to right, or 0 to l minus 1. And initially we will take the character, first character, remove it from the string and push it to the stack. This was the I have said the base case part. First we will take the first character and put it in the stack. Then we will find the minimum character in the remaining string. For that, I have written this loop which will get um, which will be checking for the condition, like if initially it will check for a. If a is 0 in the frequency table, that means in the remaining string there is no a. So the mean char will be updated to b, and it will also check for b. Then if b is also 0, it will become c, and so on. It will go up to if the smallest character in the remaining string is j, it will go up to j, and in the frequency table the value for the j won't be 0, so the loop will be terminated. Or in other case, we had the base case, we were giving the mean character the value of z. If all the character in the frequency table are if the remaining string becomes 0, then the all the value of the frequency table will become 0. In that case, the mean pair will go on updating until it reaches the value z. Z should be our last value. Then after this loop, we will be having the minimum character of the remaining string stored at the mean pair. Then we will compare that the top value of the stack and the minimum character in the remaining string. And from the explanation, we understood that if the top character is less than or equal to, we were taking the top character, and or else we were simply just putting the character of the string into the stack. So to do that operation, we will first check that there is any value at the stack or not. So we get that condition that stack is empty and not. This will give true only if there is some value at the stack. Then we check the top value of stack. If it is less than the minimum character, we pop out the top value and append it to the result. And at the end, we return the result. So let's submit this solution, and it is accepted. So thank you guys. That's all for today. Hope you guys understood well and subscribe, and thank you.